Right, good day guys, welcome to another week of online computer science, and we're going to continue with the mini project. The story so far, we've conducted an interview. I'm role-playing a client. You guys identified a set of questions to ask me to see if you could elicit some understanding as to what I wanted in my system, and then based on that particular interview, you guys now should have proposed a set of smart requirements that you think define precisely what I want in my finished system. Okay, so I'll talk about work submission and what should be due when at the end of the presentation, but subsequently to identifying the requirements, we've then begun to think about design work for the application, so moving into the design stage of a project. Okay, so types of requirements. So in terms of design work so far, I've asked you to focus on two things. One was the prototype, which if you check the previous presentation, you can find some information about what the prototype is and what I'm expecting you to do with that. And also we introduced this idea of designing the actual structure of the code a little bit and thinking about that through producing a flow chart. Okay, so they're the two aspects of design that we've talked about and discussed so far, and if you need help with those, as I just said, refer to the previous video. Just going to have a look at two other areas today, which will be common to most of your year 2 projects as well, so good skills to gain understanding of. One is a straightforward one called a data table. Okay, so I'm going to run through what this is and why it's important in relation to design in a second, and then also a little bit of pseudocode design, the one that most computer science students dislike doing, but planning the code on paper before you actually write it, rather than just charging in like a bull. Okay, so so user interface prototypes. So I've talked about this in the previous lesson, and they should be submitted as part of the work along with the requirements, and the flow chart as well I've also discussed. Okay, so yeah, just the importance here of also getting familiar with a free online diagramming software as well, which will be useful certainly to your year 2 projects as well. Okay, so I'm going to go back to the data table, and to understand one of the key focuses of the data table, you need to introduce this word validation, which may be a word that you're familiar with, it may not be, so I'm just going to kind of run through what it is first off in terms of its general definition. So the general definition of validation is to restrict the type of data or the values that users can enter into a computer system. Okay, so to a computer system. So validation can help ensure that data is reasonable, but it cannot ensure that it is 100% accurate. Okay, and there's a kind of famous acronym that relates to this, and you can see it in this image on the right hand side, and it's called GIGO, garbage in, garbage out. Okay, and the basic premise here is that if you allow garbage data to be input and captured by your programs, you're then going to get garbage information produced as an output of that. Okay, so what we've got to do here is apply, where possible and appropriate, we need to apply different validation rules to try and ensure that this data is as good and as accurate and as reasonable as it possibly can be. Okay, so it's just a basic fundamental principle of designing software. So to do that, you need to be aware of different validation types. So I'm just going to run through a couple of them. You will be familiar with them, of course, because you've spent probably many hours inputting data into various systems at different points in your lives. So hopefully most of these will kind of make sense, but we're just bringing them to your sort of conscious awareness so that you can apply them to your projects. So the first one is we've got a presence check, something called a range check, a format check, a length check, a lookup/list check, a type check. There are more than this, by the way, but we're just running through some of the basic ones. Okay, so in this particular screenshot, which of those validation methods is being used? Well, you can probably guess actually that one of the most basic form of validation is a presence check, and we can see actually when I've tried to submit this particular Google sign-up form, I can't submit it because I've left each of these fields blank. In fact, if I left any of these fields blank, the form would not submit because they are all required fields. Okay, how have they done that? They've used some presence check validation to make sure at least something has been entered into the field. The next one that we've got, so we've got an email address being input, and you can see here, well, in fact it might be a password that's being input actually, so it's a password, yeah, so it's a password that's being input, and you can see here that I need to use at least one number or symbol in that password. So clearly what I've input so far isn't deemed secure enough by this particular system. Now the particular type of validation that's being used there is a format check, because the data that I'm inputting has to meet a required pattern. In this case it needs to include a number or a symbol. So yeah, a format check. When there's a pattern to the data that you want the user to follow when inputting information, then that's what you want to use. We could also apply a format check to the email address field. If you think there's a very distinct pattern to an email address, a valid email address, isn't there? There's a username at the start, you then have the @ sign, which is part of the format, and you then have the domain name, you know, outlook.com, etc., googlemail.com at the end, the domain name at the end. So there's a distinct format or pattern to that particular piece of data. Okay, and if the user inputs an email address without an @ sign, then clearly that's an invalid email address and should be flagged by the system. It shouldn't be allowed to be captured. Okay, so the format check. So lots of date is another common one you'll see for format check. So date, DD, month, month, year, year, or year, 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 year. Yeah, so lots of different formats. So that's the format check. Nice straightforward one, this one. So particularly common one on password fields, but you've got a length check here, ensuring that a minimum number of characters have been input. A very, very common one as well. So here we have what's called a list box check. So rather than the user actually having to type any values in whatsoever, where they could easily make a spelling mistake, for example, they have to select from a group of predefined options, and in this case 12 months of the year, January to December, etc. So you just pick from the list box, and yes, the user can still select the wrong month, but the point is the data that's captured is at least going to be reasonable. Okay, so hence the reason why validation can ensure the data is reasonable, it can't ensure it's accurate. Okay, same thing for gender as well, which obviously makes sense in this context when you've only got a limited number of options to choose from. Okay, just contrast that with this one at the bottom, which is slightly different to a list validation. This would be called a lookup validation, and you can see here what happens is that you've input a postcode in this case, and then we have a list of valid addresses that then appear that are registered at that postcode. So obviously this makes much more sense when we're looking up a value, but we can't put it in a list box really, because we've got so many different postcodes. You know, if I had to do that on this particular drop down box, you know, how many postcodes are there in the UK? There's too many. So it makes far more sense to look up a value from a set of, you know, from a database, and then offer those options, which become much more manageable in terms of, you know, each postcode will only have a certain number of addresses registered to it. But again, you know, if that's my address there, then I select it. As a user, I've not actually had to input or type anything in myself. So again, increasing the likelihood that the data is going to be reasonable and more accurate. Okay, range check, very common one as well, and again, you know, often one that you can apply, and we have applied actually already to some of the programs we've written in computer science. So in this case, we've got a range check on the year of birth. Okay, and I think you guys might remember doing a program on this earlier this year, but obviously you need to define what a reasonable range for a date of birth is. And so you can see on this particular Google system, obviously anyone over 200 years old is not going to be accepted and looks unreasonable from Google's point of view, so they're not going to accept that as a valid input. Okay, so you can define the lower end and the higher end boundary of that, as you'll remember in the program. So range check, a very common one that you would be expected to apply. Okay, and the last one is just a simple type check, and we can see here we've got this issue where in this particular field it should only accept numeric values, and obviously the validation is kicked into life here, and it's not going to accept this particular input because we have two letters that have been input instead. Okay, so once you've got the basic understanding of some validation rules. There are one or two others as well which you might want to think about and look into for your projects. I think that should be enough for the mini project. What I want you to do then is to think about your particular program that you're creating. So the tic-tac-toe, and in this column here, the field names, you need to list any manual inputs that the humans might make into your program. So for example, entering a name, a player's name perhaps you might want to specify, or there's not going to be that many actually in the tic-tac-toe. Perhaps also you might have an input for the number of games that you want to be able to play against an opponent perhaps. Okay, and then you're just showing that you've thought about the design of that particular field. So in terms of its R basically means, is it a required field or not? So does it need a presence check, yes or no? Does it need to be populated? And obviously if it's a yes, then the game wouldn't start until you've actually input that particular value. The data type, the length of that particular field, so you might put a character limit. So you might say on an email address here, for example, no more than 100 characters can be captured. This is probably the key bit though. This links back to what we just talked about. So what validation might be suitable for that field, and what specifically would it be? So in this case, if it's a format check that's been applied, what things would that format check be looking for? I'll show you a different example of that in a second. Default value is just maybe if it pre-populates to a default value. So obviously most forms that you complete, the default value is just blank. Sometimes you might want to pre-populate a value. So for example, with player name, you might want to default that to player 1, and then they have to change it, for example. Could be a way of playing it. You might want to ensure that they do actually input a name. That's up to you. It's a design choice. Okay. Description of the field, just say what it is, and a typical piece of data is literally an example of what might be captured by that field. Okay, so that's what the data table is. And where you do use inputs in your particular program, in your mini project, do want to see that you thought about the design aspect, and as I said, particularly focused on the validation side. Okay, here's another example that you can see as well, and by all means you can use this example too. And you can see again the data types that have been listed, and then I like this one a little bit better because it's a little bit clearer in terms of its precise validation that's going to be enforced. Okay, so that's the data table, but you're not going to have a huge amount of content in that. The other thing that I'd like you to produce is some pseudocode. Okay, so only for a small aspect of the program though, so I'm not going to expect you to kind of plan the entire program in pseudocode and then actually create it, but what I would like to see is just a little example of pseudocode for a particularly important algorithm in this particular game, which is obviously checking whether someone has won the game. Okay, so remember the format for pseudocode. You might want to log on to Moodle and just kind of refresh yourself on some of the notation for pseudocode. But based on the design of your program, can you produce some pseudocode for how the check win procedure is going to work? Okay, when you have done that, just submit it and type it up in a similar fashion to what you can see on screen. Okay. The last thing that I just wanted to talk about, actually, and it's relevant to the previous slide as well, is that obviously in this project you've got an opportunity to practice trying to get in some of these high level skills which improve the mark of your project. So if you feel confident with OOP and you want to have a go at making an OOP based version of the game, then that's great. That's going to get you more marks and score more highly in terms of the skill of programming that you're showing. Okay, if you want to stick to some of the skills that we've learned this year, to subroutines and procedural programming and parameter passing, then that's good. It's not going to score you as highly as OOP, but I would still accept that. Okay, so you've got a bit of a decision coming up there. If you are going down the OOP route, then just a couple of examples here of maybe potential classes that you might want to think about including. Possibly. Okay, so you can pause the video and sort of have a look back over these and see if they help kind of formulate in your mind how you might go about doing this. Last thing I'm going to do in the last 20 seconds is just clarify what's due. So for today, can we make sure please that you've got the project file uploaded, a set of requirements, and the prototype of the game's interface. I'm going to give you a little bit more time for the flowchart and the remaining pieces of design work, which I'm actually going to ask to be submitted by Friday. Okay, that's everything from me. I'm just within the 15 minutes.